Now we will focus on math. So let's say this circuit is given and the phase sequence ABC is already mentioned. So let's focus what are the parameters that are asked. So first of all, EAN, this is given on 120 degree angle 0 degree, but for phase B and phase C, the angle theta 2 and theta 3, these are asked, that are not given, but the phase sequence is already being told. That means ABC is the phase sequence. So since the phase sequence is ABC, so phase sequence is ABC, and then EAN, this is already given. So obviously we can write EBA since ABC, so second one should be B, so EB should be at minus 120. And similarly the third one, this should be plus 120 degree or minus 240, anything. So there we have found the theta 2 and theta 3, since they are written as theta 2 and theta 3 and the phase sequence is given. So from these informations we have derived the theta 2 and theta 3. Now they find the magnitude of line voltages. So phase voltages is given. So phase voltages is given E5, all three phases are given here, all three are given. Now you know that the line voltages is √3 times of phase voltage, right? Previously we have derived. So from this expression we can derive the expression, and here only magnitude is asked. That's why we can use just one formula, that is √3 of E5, since all three phases has same magnitude here on 120 degree. So 120 degree multiplied by √3, this comes to 0.08 volt. So this is the magnitude of line voltage of all these three phases. The third question, find the line current. So line currents, that means this current IAA, IBB, ICC, these are asked. So you need to determine this line current. So you can understand that this line current, that means this current is, I can say, the voltage available or VAN divided by this impedance, right? Since simple law, current equal to voltage over impedance. So this formula has been used, and I already showed you that these are equal. So then VAN over ZAN, and VAN, this is equal to EAN. So from where we can write, this was our A voltage, A phase voltage on 20 degree 0 degree, and our ZAN was 3 plus J4. If you notice here we have 3 ohm, yes, so we have 3 ohm resistance and 4 ohm impedance, 4 ohm inductance. So from where we can write 3 plus J4, and this is a balanced phase. That means in all three phases the impedances are equal, the branch impedances. So all three phases 3 plus J4, these are divided by corresponding voltages. So first one 120 0, second one 120 minus 120, third one 120 plus 120 degree. So this appears as the line current that are being asked. And the last question, that is show that IN equal to 0. That means IN is the the current in this neutral branch. And remember, whenever we have a balanced three-phase system, the neutral current should be 0 ideally. So let us discover it. So this is a balanced phase, obviously, since all phases has equal impedances, 3 plus J4, 3 plus J4, 3 plus J4. So this is a balanced phase, so IN should be 0. So let's check it. Previously I already derived IAA, IBB and ICC, and if you apply a KCL at here at this point N, let me clear it all. Okay, so here if you write a KCL, so you can understand that this is the current leaving. So IN, this should be all entering current. That means this should be equal to IAN plus IBN plus ICN. This is written here. IN, this is the summation of IAN, IBN, ICN. And obviously these currents equal to the line current, since this is a YY connection. So we have already derived this in this question number C. So this is IA, IBB, ICC. Then if we add this 3, and if you use the calculator or other manual operations, then you will have 0. So since this is a balanced phase, this should be 0, and this is already verified. Now do this example math at home as homework. Now let's focus another example, which is a delta system. That means we have a delta generator and also we have a delta load. So let's focus what are the parameters that are asked. First of all, find phase angle theta 2 and theta 3. So similar to our previous maths, we have AB given, and for ECA and for EBC, the theta 3 and theta 2, they are not given, but the phase sequence is given as ACB. So since it is ACB is already given, then we can write EAB as the reference that was given, and then ECA, since it was ACB, so second one should be ECA. So ECA is at minus 120 degree, and third one, that is the B phase, so EBC should be plus 120 degree. So from here we can write it the theta 2 and theta 3. And second question, find current for each phases of the load. So that means at load side you are asked to calculate the phase current. That means ICA, IBC and IAC. You are asked to determine these values. So let's focus on. So first of all, since it is a delta connection, and you know that for delta connection the line voltage and phase voltages are equal. So remember these terms. I am summarizing it again. For Y connection, okay, let me show you. Remember this one. For Y connection, line current equal to phase current and line voltage equal to √3 times of phase voltage. And for delta current, line voltage equal to phase voltage, and the line current equal to √3 times of phase current. So remember this expression. This will be required, I think, in all your engineering lives. Now we can write this, since this is the delta connection, and again VAB equal to EAB. Let me show you. So here VAB, EAB, that means this voltage, right, from A to B, and this is connected basically across this small a, small b. If you notice, this is connected here. So we can write it this VAB that is available at this line. This is supplied to the load side A and B. So that's why the line voltages from this source to load are equal. So these are written here. VAB equal to EAB, then VCA, ECA, BBC, EBC. And now the current. So previously, just like our previous math, we can write the current is equal to voltage multiplied by impedance. Since they are all phase components, so phase current equal to phase voltage divided by impedance. So phase voltage was 120 0 degree, and our impedance was, if you notice, we have a parallel connection here. So here we have 5 ohm resistance and 5 ohm capacitance, and this is also balanced phase. So 5 ohm, 5 ohm. So parallel combination has been written. That means you need to calculate the parallel equivalent resistance that is found here. So from them we can determine the phase currents. For IBC you should use the VBC, and for ICA you should use the VCA, and the impedance of all these three branches are equal. So by this process you can determine the currents of all these three phases. And the last question, which is find magnitude of line current. So only the magnitude of line currents are being asked. You already calculated the phase current, so you know that line current is equal to √3 times of phase current. That means this magnitude, that is 33.9, if you multiplied it with √3, it will give you the line component of current. So this is the answer. So since only magnitude are asked, so this is given here. And also do this example math 4 or 24.2 for in 13th edition as homework. So thank you. I can end it here.